now I got 4 terms. A group comes out of here.
4x.
That'd be
2x
plus 5
plus 5 plus 3.
2x plus 5.
2x plus 5.
And now you know you're on the right track.
Yeah.
I saw a couple people do what I said was a big mistake. Like this is plus and this is minus, and you still went ahead and did the next step and just put them all down there. No. What this is trying to tell you, if they're not the same, is that you made a mistake.
Right.
You either didn't take a negative out, or you didn't take enough of a GCF out, or something. It's not saying, I don't know, just keep going. Cross your fingers. It's telling you made a mistake, go back and take a look. But here we're fine. These are the same. They come out.
4x plus 3.
Cool. And if I did multiply that out, it would come out to be this. That'd be a good check. Cool. Just to give you, now, just on the side here, John was pointing out that it took me like a couple seconds just to make sure. I don't know if you guys noticed, I put this down first and I put this down first when I was trying to make a problem. And what I was thinking in my head is, well, 8 is 2 times 4, 15 is 3 times 5, 26. Okay, 26 will work. 5 times 4 is 20. 3 times 2 is 6. So 26 would work in the middle. What else would work in the middle? 12 and 10, so 22 would have worked. You guys kind of see what I'm saying? I mean, if you don't see what I'm saying, it's okay. But if you do see what I'm saying, this is the part of playing with numbers that you could use to actually factor this quicker. But really, this isn't that long of a process, truly.
How fun.
Okay, all right, okay.
Make.
Oh, I see now.
All right. So I think that's basically as far as we made it. That was the last type of problem we looked at, was a trinomial that was ugly, right?
Not as ugly anymore.
Any questions on that factoring we've done so far? GCF grouping, the 3 terms, either just figure out the numbers or surefire method, right? Or any other method you use that's not bottoms up.
But when it is okay clear, and there's minus and plus, how you can manage?
All right, let's see.
Plus.
So let's so if I had, well, let's see, if I had did this, that's good, John. If I had done this, made that problem. And actually, you have to be minus here. So then what I've done, I've still got 20 and 6, but I've made like the 20 negative now. So I would still do the same thing. 8 times negative 15 is now negative 120. 20 and 6 still work, but
One has to be negative.
which one has to be negative?
The smaller one. No.
Careful. The bigger
The
one's
bigger
got to be
one.
negative, so overall it comes out negative, right? I gotta owe somebody more money than I got, so I still owe money at the end.
Because you're going to have a bigger negative number that way.
Exactly. So what I was saying earlier is, if I do have a choice between negative and positive, I always put the negative first. Because if there's a minus here, that's normally where negative mistakes come in, right? And now you just do the same thing we did over there, right? You group.
Yeah. I always think like the bigger number, always take the side of the middle number.
Yes, cool.
What was the other 2 numbers that you were pulling from the 26?
What do you mean? It could be 12 and 10.
It doesn't matter?
No, it would be a different problem.
Okay.
It would come out to a different answer, but in setting up the problem, there's a lot of things I can put in there.
Okay.
In setting up the problem, there are a lot of different numbers I can put in there.
So it'll be 15 and 8 now.
It's got to be some cross product for these guys.
Okay.
Or I can break this up a different way. I can break it up at like 8 and 1. Then it could be 40 and 3.
Okay.
So I could have put a 43 in the middle. It would have worked. And again, if you don't quite get that, it's okay. But the more you get that, the other factoring methods you could use easier. But this is really, I don't think this is really all that much. To tell you honestly, I mean, and it gets you there relatively quickly to the end.
And if it is plus and minus?
Oh, so if I would have put minus 6 plus 20? I mean, sorry.
One is a
Plus
one is a
6x minus 20x, like that?
Yeah.
Okay, so what would you take out of here?
2x.
Okay.
And 4x.
X.
Plus 3.
Now you know they have to both be positive. These are both negative currently, so what do you have to take out?
A negative.
You have to take a negative.
Negative
5.
5.
It's 4x plus,
Now here's the mistake I saw on the test a lot.
Yeah.
no, plus.
So two things. I made a mistake because I took a negative out, that should change. And secondly, I can't go to the end because these are not the same, right? That last step is still GCF. It's just a big ass GCF. Oh, he's busy. I gotta be careful. Little ears in the room, I gotta be careful. It's just a big old GCF, right? Not one thing, it's this parenthesis thing I can take out, but I can't because I made a mistake. I go, oh, I made a mistake. Okay, now I can take it out.
Yeah.
4x plus 3, 2x minus 5, or the other way around,
Right.
right? Okay.
What I mean, that the main equation minus and plus.
Oh, with a plus here.
Yes.
Well, okay, in that case, I couldn't just make that a plus, it would be prime.
There you
It would, if I did this, I don't want to spend too much time on this, but if I did this,
Yeah.
this would be very evil. Because I need two numbers that multiply 120 and add to be negative 4. They have to have the same sign. So if you try adding to be negative 14, like negative 2 and negative 12 make negative 14, but they only multiply to negative 24. You run through all your possibilities, and you're not going to find anything. The closest you can get is negative 7, negative 7. That's 49, which is still not 120. That would be prime. That would be an evil prime. Normally, if I give you a prime number, I'm going to make it a little bit more obvious, like this here. Now, why should that be obviously prime? What do you need? Two numbers that multiply to be?
Plus 4.
Okay, now this is scary. You would need two numbers that multiply to be 1 and add to be 4. Are there any? The only things that multiply to be 1 are 1 and 1. They make 2.
Right.
So that's why this is prime. Because there are no numbers that do what you need them to do. Therefore, can this thing be factored? No.
So it is not always when it is minus and plus it is a prime.
No, definitely not. No.
No.
Yeah, definitely not.
Oh.
Yeah, be careful. I mean,
So-
here it's prime, but
Yeah.
I could make, let's make a little tiny one, like x squared minus 6x plus 8.
Fine.
We'll multiply to 8, adds to be 6,
4, 2.
and they both have to be,
1 is 4.
see, no problem.
Ah.
It's just, the last thing is positive, they have to have the same sign, so if the middle is negative, they both have to be negative. Cool. Okay. So I want you've got to understand separately how each procedure works. And then you have to be able to identify which situation you're in. That's the two-step process you have to do to learn this. Right? The nice thing is, the problem itself tells you what to do. If there were 3 terms to do this, 4 terms to do this, I always try GCF first. You know, it kind of tells you what to do as you go through it.
Oh, so that's how you get prime.
Yeah, from this guy, nothing will work, so it's prime. Yeah.
Because you need two numbers to multiply to the middle one, but they have to
Well,
add.
multiply by 120, but add to be negative 14.
Right.
I can make a list of everything that adds to be negative 14, and it won't make 120. They just can't be big enough.
Okay.
Okay. So, to get into the last section, what to do when you have two terms. Let me show you how to look at one of them the same way we did this guy. For example, if I had x squared minus 49.
X.
Real quick, what's the middle term?
It has to be
Zero. So I need two numbers that multiply me negative 49, but add to be 0.
Negative 7, positive 7?
Exactly. So they have to be the same number, just different signs. And now you see why this is called difference of squares. That last number has to be a square, so that it's the same number multiplied by itself, different signs. If I put an 11 there, it would not work with whole numbers, right? There's not a number times itself that equals 11 whole number. So here I'd have x and x, 7 and 7. If they're opposite signs, the middle term cancels.
Yeah. But if it is plus 49,
We'll get there. I want to go over a few more that work first. So I don't have to look at this that way. I can look at it much better. If there's two terms, it could either be squares or cubes. I know this is squares because I can cut everything in half. And when I say in half, I mean multiplicatively. Don't cut this in half like 24 and a half. No, multiply 7, 7. Right?
Yeah.
So this is actually, the difference of squares is what I call a thank God problem.
Different squares.
Or whatever deity you enjoy. Thank the gods, just to cover everybody, so you don't piss anybody off. Right? So this is, if I had, anytime I have two terms, like x to the 4th minus 25. There's two terms.
X squared.
X2, X2.
There's no GCF,
Yeah.
right? There's two terms, and they can both be cut in half.
Yeah.
X squared.
X2, X2.
x2, x2,
X squared.
Minus 5 plus 5.
5, 5, minus plus. That's why I call it a thank God problem, because it's two terms. You identify what it is. If you can identify it as a difference of squares, it will always be easy, because you just cut everybody in half, minus plus. And you're guaranteed it'll work, because that's the only way the middle term can cancel, is if you end up with the same things in the middle, different signs. So here, let me jump to this, so you guys are with me. 81 W8 Y4 Z10 minus 64 A100 B squared.
Excuse me.
Now see, you guys, I keep trying to show you what not to be scared of.
9.
I don't care that I loaded it with a bunch of crap. You just need to make sure you got enough lead to do the problem. It's two terms, right?
Yeah.
Yeah.
GCF?
8.
Any GCF?
No.
8 won't go into 81.
9.
9.
9 won't go into 64.
8.
8 won't go into 81. I love it. So is there a GCF?
No.
No.
All right, thank God. So we'll get off of that. You always check GCF first, and there isn't one. Now you say to yourself, are there 4 terms, 3 terms, 2 terms? There's 2 terms. It can only be squares, or the thing we haven't talked about yet, cubes, which is where I can cut everything in thirds. I can cut everything here in half, can't I?
Yeah.
So it must be squares. The minute you know it's squares, you say, thank God. Here I need some big old parentheses, right?
Right.
But then you just cut everybody in half.
9.
Yeah, 9 and 9.
W4.
W4,
Y
Y squared,
2.
Z to the 5th.
Z5,
Minus 8A.
Minus, yeah.
minus plus 8,
8.
A50,
And B to the
B1.
I should.
I mean, come on, right?
Yes.
Because it's a difference of squares. It should be easy. I don't care how many letters I've loaded into it. Who cares? I just loaded a bunch of crap in there. It is a difference of squares. If I multiply the middle term, I get minus 72, blah, plus 72, same blah, cancels. That's why the middle term's gone. Right? I've set it up so the middle term will cancel.